the notes for section 2.6. We're going to do this entire section in just one set of notes. I don't think they'll be too long though. So we're going to be talking about the algebra of functions, which basically means that we're going to be taking functions and putting them together by either adding, subtracting, multiplying, or dividing them. Some of you guys have not been doing so great with actually writing everything on the notes. You should pause it and write down all of those words right now, okay? You should also write down this first problem right here. So it says, let f of x equal x plus 4 and g of x equals x squared plus 1. We're going to find f of 2 plus g of 2. You need to write down that problem. Pause it right now and write that down. All right, I hope you wrote it down. So what we're going to do here is we know how to find these things on their own. We know how to find f of 2. That means we put a 2 in for the x. And we know how to find g of 2. That means we put a 2 in for the x. So all we have to do is find those two separate things, and then we add them up. So I'll find f of 2 here in red. So I'm going to do f of 2. Remember, that just means I'm plugging a 2 in for that x right there. So it equals 2 plus 4. So that means that f of 2 equals 6. Now I'll find g of 2 in blue. So I'm going to be plugging a 2 in for that x right there. So g of 2 equals 2 to the power of 2, or 2 squared, plus 1. So that means that g of 2 equals 2 squared, which is 4, plus 1 is 5. So I've now separately found g of 2 and f of 2. It wants to add up f of 2 and g of 2. So what we're going to do is we're going to do 6 plus 5 that I got for g of 2. So our answer is 11. So whenever they ask you to do that, you're just adding them up, or there's going to be subtracting, dividing, and multiplying that we'll also do. So here's the 4 things we'll run into. When they say f plus g of x, that really just means you're taking f of x and adding g of x to it. You could find them separately if you wanted and then add them up. If they say f minus g of x, that really just means you're finding f of x and you're subtracting from it g of x. If they say f times g of x, it's supposed to be a little dot right there, then you're going to do f of x and multiply it by g of x. And then lastly, if they say f divided by g of x, you're going to find f of x and divide it by whatever g of x is. That slash means division. I know it looks like a fraction maybe, but remember, a fraction is division. That's what that means. So we're going to do an example right here where we find all 4 of those things. All right, so we've got our 2 functions here. F of x is x squared minus x. And g of x equals x plus 2. Go ahead and write those down. Pause it if you need to. So the first thing we're going to find is f plus g of 4. That just means we're going to find f of 4 and g of 4 and add them up. So I'm going to be finding f of 4 and adding it to g of 4. So let's go ahead and just find those things separately and we'll add them up in the end. So f of 4 means I plug in a 4 for x in my f of x function. So I'm going to be doing 4 squared minus 4, which is 16 minus 4, and that's 12. So f of 4 equals 12. Now let's find g of 4. So I'm just plugging a 4 in for that x. So I'm going to be doing 4 plus 2. So g of 4 is 6. Now it wanted me to find f of 4 plus g of 4. So f of 4 was 12. I'm writing it right under it because they equal the same thing. G of 4 is 6. So we're really just doing 12 plus 6 here. So we get our solution 18. Alright, so now what we're going to do is a subtraction problem, and it looks a little different. I'm going to write down my f of x and g of x again, because I need to scroll down, I'm not going to be able to see it. So f of x is x squared minus x, and g of x is x plus 2. All right, let's scroll down. This subtraction problem looks a little different because the first instructions they give me are to find f minus g of x. So what that means is that they want us to just first give this in terms of x. We're not going to plug any numbers in yet. So when we find f minus g of x, remember that means we just take f of x and subtract from it g of x. So all we're going to do here is first I'm going to write out my f of x. That is x squared minus x. And then I'm going to subtract g of x, which is x plus 2. Now we need to subtract that entire function, which is why I'm putting it in parentheses. And that really makes a difference here, because it's kind of like, if you remember when we talked a lot about distribution, there's really a -1 out in front of that function. So I need to distribute that function to make sure I subtract the entire thing, both terms. So I'm going to have x squared minus x. -1 times x is minus x. And -1 times 2 is -2. So I've written out f of x minus g of x. From here, I just need to simplify. There's 4 terms there: x squared, -1x, -1x, and -2. I can combine those -1x's. So I'm going to be left with x squared minus 2x minus 2. So that's my first solution. That is the first thing they asked for, which was f minus g of x. That's where I'm just subtracting f minus g, and I'm leaving an x in it for now. So then it told me to find f minus g of -1. So you have some options here. You can either plug -1 into each of those functions individually and then subtract, or since we already found f minus g of x right here in red, we can just plug a -1 into that. So for f minus g of -1, I'm just going to be plugging a -1 into that function that I found. So I'm going to do -1 squared minus 2 times -1 minus 2. I just rewrote that equation in red, which was f minus g of x, and I plugged in -1 because I'm looking for f minus g of -1. Remember, whenever you're plugging in a number, you should think of it as in parentheses. So if your x is being squared, the whole number, the whole -1 is being squared. So here I've got -1 times -1. That's +1. Now right here, I like to think of this as -2 times -1. So that's a +2. And then I have this -2 on the end. Well, 2 minus 2 is 0, so my entire answer here is just 1. So f minus g of -1 equals 1. All right, so now what we're going to be doing is something similar, but we are dividing here. So I'm going to be doing f divided by g of x. So the first thing I need to do is write it with just in terms of x. So f divided by g of x is just f of x divided by g of x. And we write it as a fraction. So my f of x I'll write on top. That's x squared minus x. That comes from the problem. And we're dividing it by g of x, so that is x plus 2. So that's the first thing they wanted us to do in this problem. Just find f of x divided by g of x in terms of x. Now we're going to find f divided by g of x of -3. So we're going to be plugging in a -3 into that problem that I just wrote out. So I'm going to write -3 squared minus -3 on top. And our denominator, we have -3 plus 2. I just plugged in a -3 for that x value there. So now if I look on top of this fraction, I have -3 squared. That means -3 times -3, so that's 9. And then minus -3 really means plus 3 right there. Minus a negative is the same as adding. On the denominator, I have -3 plus 2. Well, that's -1. And then let's just simplify this a little more. In the numerator, 9 plus 3 is 12, and I have -1 in the denominator. And we know that 12 divided by negative 1 is negative 12. So my answer for f divided by g of negative 3 is negative 12. Last, we're multiplying here our two functions. So on this one, I think we might just want to do it separately, especially because we don't have to write it in terms of x this time. All they want is in terms of 4. Well, if you look back up, I think we already found each function in terms of 4 on the very first one. We found f of 4 is 12 and g of 4 is 6. So now we're just multiplying those. So we're just doing 12 times 6. And we get 72. So you can either do them separately or find it in terms of x and then plug your x value in. Either way it works. All right, so we're going to do a different type of example now where we start talking about the domain of these functions. So in this example, we've got some functions, f of x and g of x. And, oh, there we go. So f of x is 5 divided by x. G of x is 2x minus 6 over x plus 1. We're finding the domain of f plus g, f minus g, and f times g. Now, we're going to do this just all in one thing because what we're looking for in the domain is, well, what values can we plug in for x? And we're kind of thinking, is there anything I can't plug in for x? Is there anything that would make a denominator equal 0 because that's bad? So what we have to know is if we're going to be adding f plus g or subtracting f minus g or multiplying them, well, whatever values we can plug in for x in any of those will work for this whole domain. So we're just going to find this domain all at once. So if we look at these two functions, we can see that in f of x, x cannot equal 0 because that would make our denominator equal 0. So we know that's one part of our domain. X cannot be 0. Whether we're adding them together, subtracting them, or multiplying these two functions, x cannot be 0. If we're looking at g of x, which is 2x minus 6 over x plus 1, well, it doesn't matter what we plug in for x in the numerator, that doesn't matter. But in the denominator, we don't want that denominator to equal 0. And I know that if I put in a negative 1 for x, and I did negative 1 plus 1, that would be 0. That would be bad. So we know that x cannot be negative 1. So there's two restrictions on our x right here. It can't be 0 because that would make f of x undefined, and it can't be negative 1 because that would make g of x undefined. So for our complete domain of this function, we would write it like this. All numbers x such that x is a real number and x does not equal either of those two things I talked about, negative 1 or 0. So when you're finding the domain of f plus g, f minus g, f times g, you just find the things that restrict the domain for either of them and put it all in one thing. Okay, so I'm going to give you guys one to try that's just like that one. All right, I want you guys to try with these two functions. F of x equals x over x minus 8. And g of x equals x squared minus 7. I want you to find the domain for f plus g, f minus g, and f times g. You should be able to just write it in one thing. Just figure out what x cannot be, and then tell me that. All right, so now we're doing an example where it's a little bit more than the example we were just doing, because it says find the domain of f plus g, f minus g, f times g, and f divided by g. That one is a little trickier, okay? Including the division makes this a little tricky. So first, we know how to talk about the domain for these three. We just figure out things that x cannot equal. So if I'm looking at f of x, and it's 1 over x minus 3, well, I know I cannot have that denominator equal 0, otherwise f of x would be undefined. So I know that x cannot equal positive 3, because 3 minus 3 is 0. So there's one thing I really needed to include in my domain. X cannot equal 3. If I'm looking at g of x, 2x minus 7, X can be all real numbers for that. So there's no restrictions that come from g of x. But here's the thing. If we're including f divided by g in our domain here, that means that if we have f divided by g, that means that our function g cannot be 0 because that entire function's in the denominator. So since we're including f divided by g, we need to see what would make g equal 0, and we need to make sure and not include that in our domain. That would be bad, because if we're dividing by g, we don't want to divide by 0. So if I take my g of x, which is 2x minus 7, and let's find out what would make that equal 0. So I'm going to set it equal to 0, and then find x. That tells me what x would make this function equal 0. So I need to add 7 to each side here. I'm left with 2x equals 7. And then I need to divide by 2. So x is 3.5 or 7 halves. So I know that if x is 3.5 or 7 halves, then g of x ends up being 0. And that we don't want that to happen because we're saying that we might be dividing f divided by g for this domain. And if we're dividing by g, we don't want g to be 0 because then we'd be dividing by 0. So when we write the domain of this one, there's just one more little restriction here. We're going to say all numbers x such that x is a real number and x cannot be 3 because a 3 would make the denominator of f 0, so it would make f undefined. And x can also not be 3.5 because that would make the function g of x 0. And while it's okay for g of x to equal 0 if we weren't going to divide by g, since we included this little bit right here, f divided by g, we cannot let g equal 0. So we have to make sure that anything that makes g equal 0 is not included in our domain. So that's the last example we're going to do together. I have one more I want you to do on your own. It's just like this one that we just did. So f of x equals 3 over 2x plus 1, and g of x equals x minus 4. So I want you to find the domain if we were going to do f plus g, f minus g, f times g, and f divided by g. That last one makes it so you're going to have an extra little restriction on your x there. All right, come to class with any questions, and we'll go over the ones you guys tried on your own.